Okay, yeah, there it is. Uh-oh. There nothing is. Oh. Yeah, it does that every now and then. All right, so give that one a try. Wait. I want to get you started, so we use the time well, then I'll do roll. Basically, what you got to do when they say 300 omelets and they give a price, that's a point. 300, 312.52. And then they say 800 omelets, that's 704 thing. 70402. Those are 2 points. And you got to do what we did last time on question number 6. Excuse me, where you find the slope. You could use the M formula twice. Look back to what we did on that last one. It's almost identical from here. Do you know what I mean? Meaning first you use the M formula to find the slope, y2 minus y1 over x2 minus x1. You guys with me? This is x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. So clean that up and see what you get for a slope there. Somebody got a number on that? Was that 300 and I don't know. I can't do it. 91.5 over 500. Is that right? Yep. Okay. And then double it. So what's double 39? 678, 78.73. So there's our slope. And now use the formula, the slope formula a second time. And this time it's the plane x and plane y. Remember that? And you take one of the points and you plug it in. It doesn't matter which one. It's like I could take the 300, 312.52, for example, and I could plug, this is x, so plug it in for x1, plug it in for y1, and plug this in for the slope. Do you remember that? I could have used the other point as well. It'll work with either one. Remember that from last time? Is that making sense? So it's what we did on the last one. So they're having us find. How do you know when you're supposed to do this whole thing? Well, they want you to find a linear formula. This is like from your algebra days when you found y equals mx plus b. Remember that kind of thing? Remember they said find the equation, find the equation. That's basically what they're doing. They're saying, hey, find the equation. You know, if this was a y instead of a c of x, same thing, you know. Y equals mx plus b. That's what all those answers are. They're different versions of y equals mx plus b, aren't they? So they're just wanting us to find an equation. When they want you to find an equation, you have to, there's lots of ways to do it. Math Excel describes a different way. If you click on the question help, they show a different way. I never care what way you do anything on the test, but over the years I found this is usually easiest for students because you just keep using that same formula again and again, once with all 4 numbers plugged in, the slope formula. And then you use the slope formula again a second time. This time with the plane y and the plane x in the front, you only plug in the back numbers once you get the slope from part 1. So it's like a part 1, part 2. You guys tracking with me on that? So part 1, part 2. In other words, this was the end of part 1. So part 1 is you get the slope. And then part 2 is you use the slope formula again. I got to finish it up, but I'll let you copy that down. You plug in the slope in the front, the slope you found, the 0.783, that's going to go in the end slot. And then you can take this x and y or that x and y, it doesn't matter, and put them in the x and y in the back. And remember what we do from there? We cross multiply. right? So that's the next step, cross multiply, and basically solve for y. And then it'll be one of those A, B, C, or D answers. I'll run through roll while you work on that. Abdullah is here. And Nicholas Anderson. And Abraham. Am I saying that right? Abraham?
Yeah. Can't say it like Abraham.
Abraham? Or Abraham? Okay, even though it's an I, okay. Edward? Found? No. Name? Oh, I thought I had two. Name. I don't know if I can do that. All right. Michael is here. And Duraj Chikara. No Duraj. And Stephanie Crutchfield. No. And Lisa Gonzalez is here. And Griselda Granados. And Brandon Grogan. So feel free to check with those around you as you finish this problem up. What answer is it? You guys already get it? Anybody know what answer it is? All right, so everybody good to there? There. Everybody good to there? We all good to that? Is that making sense to that point? So when they ask you, how do you know when to do this? When they ask you to find a linear equation, like from algebra, right? You got the 2 points. That was the omelets and the price. Now omelets and the price. The 2 points, you find the slope, plug in the 4 numbers, get your slope, and then use the slope formula a second time, this time with the plain y and x in the front, and plug again a point in the back. You could do this point or that point, doesn't matter. Plug them in the back and the slope in the front. So I'm going to go to the new page. The slope is 0.783, y minus x minus, so I'll rewrite what we got there. And so this is 0.783, y minus x minus, and what was it? It was 300 on the bottom, 312.52 on the top. 312.52, 300. Okay, so now we cross multiply, right? We're trying to solve for y. Put this over 1, diagonal, diagonal. You've seen that before? Cross multiply. So you get 0.783 times x minus 300 and 1 times y minus 312.52. We good to there? And so now we distribute 0.783x minus, I have no idea, 200 something? 234.9? Thank you. And this one, I can do a 1. All right, we get to there, and now we're supposed to solve for y, right? It's always about getting y alone. Questions to that point? Do you guys want me to close the door? Is that distracting? You guys okay? All right. Want the door closed? Are you okay? Okay. All right, let me know if you want to close the door. All right, so how do we get y? Last time was get y alone. Everybody good on these? You always get y alone, right? Get y alone. So add the 312.52. So 0.783. What is that? 80 something or 78.1? Thank you. 78.1. And we're done.
77.62.
Oh, 77.62?
Yep.
You were lying to me? The calculator was? We good there? Easy to hit a wrong button. On tests, run the numbers twice in the calculator. That's what I would just do when I took tests with math and used calculator. I would just do them twice because it's so easy to hit a wrong button. Just run it twice, it'll come out the same. You probably didn't hit the wrong thing twice. Is that good? You okay with finding those equations then? Just like last time. Okay. I assume that answer was one of the ones there. Oh, it's C? B? Oh, it's minus 76.2. Yeah. Oh, wait, no, it's plus. Ours is plus. So it's B as in boy, right? It's B. Good? All right, I'm going to move ahead.
234.9.
What's that? Was there a question? Did I answer your question? You good? All right. If I'm going too fast, this will all be on the YouTube thing after class. All right. So, so here they're giving me fixed cost, marginal cost, and item sales for. And they want me to find the cost function, revenue function, and profit function. They're going to have like 5 of these or something, you know, same thing every time. Okay. First off, let's write cost function. To remember, no, there's 2 parts to the cost function. There's fixed and marginal. Do you guys remember that marginal, here's a good way to memorize that. Marginal has the m, it's slope. It's basically slope. You like the y equals mx plus b thing, right? If you just think mx plus b, this is always the marginal. I don't think that's what the m really stands for, but we'll use it. So, so the cost function is 12x plus, and then the fixed is the b. That's the 1,000. So I just wrote the cost. So again, marginal is always what's next to x. And it's like slope. And really it means the amount for one item, the increase for one more item. So it's next to x. All right, so there's the cost function. The item sells for $25. What does that mean that the item sells for $25? I'm supposed to write a revenue function, right? So how do I write the revenue? How do you write a revenue function? Well, if whatever they're selling, it sells for 25 bucks a piece. So the revenue, the amount you're going to take in, the revenue will be 25x. Where, by the way, x is the number of items sold. Right? Because if you sell 10 items, you'll get whatever, 10 times 25 is 250, right? Is that making sense there? So it's $25 per item sold. So the revenue function is 25 times however many items sold. But it costs the company, the factory, something to produce the items. What does it cost them to produce the items? Well, 12x plus 1,000. In other words, it costs the company $12 per item. But there's an initial cost just to set up the factory, to buy the whatever it takes to start making stuff, $1,000. Is that making sense how those two things work? So cost function is what it costs the company again. It's $1,000 fixed, that's like setup costs. And then $12 per item to crank them out, labor charge or materials. And then they sell them for $25 per item. So they're making a profit, but they've got to overcome their initial cost to get into the black, right? So final thing, so that's the revenue function, cost function. Last thing, they ask for profit function. There's 3 parts to this question, so they're going to ask you to enter the cost function, the revenue function, then part 3 on Math Excel will ask you for the profit function. How do we come up with a profit function? Yeah, it's just incoming minus outgoing, right? Profit is always, whoops, that's not a P there. So profit is always revenue minus cost. It's money that you take in, that's called revenue, minus the money it costs you to produce things. So the profit function then will be the revenue function, 25x, minus the cost function. Now the cost function is 12x. You got to subtract both parts. You can put parentheses if you want. I'm just going to skip that step and just distribute the negative sign. Is that okay? See how those both, well, maybe I should do it more slowly. And then so that negative will distribute to both. You're subtracting the cost function, right? Minus 12x minus 1,000. So the profit function, gather light, 25x minus 12x is 13x minus 1,000. So there's the profit function. And we're done. So we found all 3. We found the revenue function, the cost function, and the profit is always revenue minus cost. Any questions I can answer on that one? Is that making sense? Good. All right. I'm going to move on. Okay, so they're giving me 2 equations. 4x minus y is 17, and y equals 18 minus 3. If I was to bother to graph them, I'm not going to. I'm not going to graph those. But what would the graphs look like? What I mean is, would they be U-shapes, or would they be circles, or what would those graphs be? Both straight lines. We realize those are both straight lines. How do you know? How do you know when you look at an equation like that first one, or the second one, that something's going to, the picture, if you were to do the picture, would be a straight line? How do you know? Powers, huh? If they both, right on. They both just have first powers. There's x to the first, y to the first, y to the first. If there's not like second powers or higher powers, if they're just first powers, then those are what we call linear equations, meaning their graphs are straight lines. So if I was to bother to graph them, I'm not going to, but one would be a line going down, one would be a line going up, and they would have some point of intersection. That's what they want me to find without graphing. I'm not going to graph a thing. But behind the scenes, that would be the picture that's going on. They want me to find where those two lines intersect. So how do I use the equations and find where those two lines intersect? What do I do?
Elimination or substitution?
Yeah, either way. You can use elimination method or substitution. I never care. This one's probably going to be most easily done by just grabbing this right here and plugging it in for y right there. Substitution. Does that make sense? What I'm doing. See how that second equation says y equals 18 minus 3x, meaning y is the same as 18 minus 3x. Which means wherever I see y, I'm allowed to replace it with 18 minus 3x because it is 18 minus 3x. It equals 18 minus 3x. That makes sense? So we always plug one equation in. We could have actually started with the top equation, got x or y alone, and plugged into the bottom. But I'm starting with the bottom because it's so convenient. It's already got y alone. So I'm going to plug the bottom into the top. You always plug into the opposite equation. So we have 4x minus, you got to put parentheses, y. Why do I have to put those parentheses that I just put? Why would it be wrong if I did not put the parentheses? What if I just wrote this? Why is that not true to the meaning of the equation, to not have parentheses like that? Because I didn't really subtract y. This equation said you take 4x and then you subtract all of y. I only subtracted the front part of y. I never subtracted the back part. This is also part of y. This whole thing here is y. And I didn't really subtract the whole thing unless I put parentheses. Do you see that? So you got to put parentheses, and then, yeah, that minus distributes, which really subtracts all of y instead of just the front part of y. That's why parentheses are required. All right, so what do we get? 4x minus 18 plus 3x is 17. Gather like terms. What's that? 7x minus 18 is 17. Am I going too quick? See what I'm doing there? We good so far? So I'm just taking the bottom equation where it's got y alone, and I'm plugging it into the top equation. And then writing out that top equation. Distributing the minus. It was minus 18. A minus times minus is plus 3x. Gather 3x and 4x is 7x. Finish solving for x. Add the 18. 7x is 35. Last step. And divide by the 7. X is 5. So I got x is 5. How do I get, I need y also. How do I get y? Yeah, plug it in. I'm kind of running out of room here. They move it up here. I don't even know what the graph really looks like. So I'll just get rid of all that. So come on up here. So x is 5. Plug it in. Plug it in where? Anywhere you want. Really, you could plug into any equation you want. This one looks easiest because y is already alone. You could do the other one though, but this one is nice. Since I want y and y is already alone in that second one, that'll be easier. You could use the first one. It would work also, but it had a little more steps to it. So 18 minus 3 times 5. What's that? 18 minus 15. Y is 3. So the answer is 5 comma 3 because it's x comma y. They want. Notice how they say they want an ordered pair. So that means they want the two numbers with the parentheses and the comma. That's an ordered pair. 5 comma 3. X comma y. That's the point of intersection. That's where those two lines would intersect if we bothered to do the whole graph thing. Are we good? A lot of algebra. This section is just like an intense algebra review. Solving two equations and finding intersection points. No questions? All right. Okay. Okay, they're going to ask us a million things on this one. So first off, insurance company claims that for X thousand policies, its monthly revenue in dollars is given by boom. So basically, we have a revenue function, right? That's money they take in. That's what they get from their policies. And its monthly cost in dollars, and there's the cost. That's what it costs the company to produce policies. They got to pay employees to, do all the paperwork, so it costs them something to do policies. Plus, they have an overhead cost of, an initial cost of $16,200 to, I don't know what, buy the building they use and all that stuff. All right, so find the break-even point. What does that mean, break-even point? They're going to ask us this a lot. Yeah, where the balance, where the company just breaks even. They're not making money, they're not losing money, they just break even. And what happens when they just break even? What do we have to do? They intersect, which means they are equal to each other, right? At the break even, whenever they ask you for a break even point, that always means profit, revenue equals cost, meaning the money coming in equals the money going out. You're exactly breaking even. Profit happens when revenue is greater than cost, huh? So revenue equals cost. So I just take the revenue function, 225x, and I set it equal to the cost function, 180x plus 16,200. All right, can you guys solve that one? So go ahead and solve that one real quick. All right, so how do we solve for x? Subtract. Remember when you have x's on both sides, you just get rid of one of them. I usually get rid of the lower one from both sides of the equation. Remember that? I'm glad to help with all these algebra things. I know that's the part of this class that really is hardest for people. It's all the x moving around stuff. So please ask. I'm glad to help. That's what I think we should spend our time on. 45x is 16,200. And then how do we finish solving for x? Yeah, just divide by the 45. Somebody have a calculator? 360? Okay, good, thank you. 360. Now, do you know what x is, like in the real world on this problem? What is x? Is it like...
Number of thousands of policies.
Yeah, you're right. Yeah, there it is. You're right, totally. X is 1,000, so that's 360,000 policies. So that's how many policies the company needs to produce in order to break even, right? To overcome their initial setup cost, in other words. If they crank out 360,000 policies, they're just breaking even. Anything more than that, they're making profit. That's basically what we found. So that's the first question. We good with that? Part B, notice that we have to graph the revenue and cost equations. So let's do that. Let me bring that. If you didn't get that down, again, it's on the YouTube channel later. So let's do part B. Now, graph the revenue and cost equations. How are we going to do this? Well, let's start with the revenue. The revenue is 225x. Treat the R and also the C like it's the Y. Just pretend that's the Y in the front. That's the same thing. It doesn't matter. This is just going to be my Y. So this is like Y equals mx plus b. The b is 0, huh? Right, there's no b out here. The b is 0. So what I think is going to be easiest for this particular one with the Math Excel thing is just to make a little table. And remember, it's a line. It's a straight line because it's just x to the first power. Right, you with me? It's not going to be a U shape or have any curvature at all. It's nothing more fancy than a straight line because x is just to the first power. So that's a linear equation. And so when it's a linear equation, you only need 2 dots. That's all we need is 2 dots. So 2 points. So I'm going to plug in 0 because that's just super easy. when you plug in x equals 0, instead of y, it's really r equals 225x. Y is the r. So r equals 225 times 0, which is just 0. So that's the dot 0, 0 right there on the graph. And now I need one more dot, right? We just need 2 dots to be able to get a straight line. What other dot can I get? Well, you could plug in anything you want, but to make it easy for the graph, guys, what I think it would be best is to plug in 90. Just because that's a point on the graph. You track it with me? You see how I'm coming up with that? I have to use the graph Math.Excel supplied to me. You know, on a test, if this was a test, and I didn't give you a graph, or I just gave you an axis with no numbers, you plug in any number you want. You know, just give me 2 points, and that's great. I'll be happy you get my credit. But since Math.Excel gave me particular x values, just plug one of these in. It really doesn't matter which one. Any of them would be fine. I'm just going to do the 90 because it's just the next one. Any of them would be fine. I'm going to plug in the 90 for x. So r will be 225 times 90. Somebody got that one for me? 20,250? Thank you. 20,250. I can squeeze it in here. 20,250. So that's another point. Where's that? Over 90 up. I think that's right here. Now, I know that because I just did it in my office a half an hour ago or 45 minutes ago. So let me show you how you will know on Math.Excel. But everybody good so far? In a minute, I'll go back over to this is just a copy, this is just a picture of the page. It's not live right now. I'll go back over to the live page and I'll graph it with you. But that will be right, that is the dot, and then it'll make a line through those 2 spots, which is the revenue line. So before I go back over and do the live, let's also do the cost function now. Okay, so now how are we going to do the cost function? Same thing. The cost function, did I just make it do something funny? So the cost function is 180x plus 16,200. Is it all on the screen? Yeah, okay. So same kind of thing. I'm going to make an x and a y, but the y is really cost. And again, start with just 0 because that's easy. So the cost function will be 180 times 0 plus 16,200. So that's just 16,200. So that's over 0. I'm just going to draw an arrow. Over 0 up 16,200. So that's this point right here, isn't it? Over 0 up 16,200. That's 1 dot on the cost function. We're supposed to put the cost and the revenue lines both on the same graph. And now I need one more. I'm going to plug in 90 again. You don't have to. You could plug in any of these x values. You know, I'll just do 90 again. So plug in 90. The cost will be 180 times 90 plus 16,200. Somebody have that? 32,400. Thank you. I'll just put it there. And so what's that? Over 90 up 32,400. It looks like it's right there, doesn't it? Over 90 up 32,400. Everybody see it? Now, these are x, y guys. X, y, x, y. I mean, the y is the c, right? This is cost. This is dollars, which is cost or revenue. It's my y values, right? So over 90 up 32,400. Connect them, and we'll have a cost function. And where do they break even? What was the answer to part A, the break-even point? 360. So I know they're going to actually cross. Actually, I could have used that, huh? I know they're going to cross at 360 right there. So it's gonna. So the graph will look something. I'm faking it. You know, I'm bending the line to make it work. But I'll do it for live, and it'll look much better in a second. But that's the general idea of the 2 functions: the revenue function and the cost function. Let's go back and do it live now. Is everybody good to that point? Everybody got that copy down? Is that good? All right. So I'll go back over here. Okay, so it says when x is 180. So it wants me to first off do revenue. What is from the graph? That means by looking at that graph, how do you find what revenue is when x is 180? Can I make this big? Well, it doesn't do anything on your screen. Okay, never mind. So when x is 180, it's right here. Whoops, I didn't do that well. It's right there, isn't it? It's not there. Everybody see that point? So this is X is 180, and this is the revenue function. Remember that was the first one? This is revenue. The other one's cost. So when X is 180, I didn't draw that very well. Where does it hit? I can't even tell now. Let me erase it. When X is 180, boom. Yeah, 40,000 right there, huh? So here's the revenue function again. Yeah, so it hits at 40,500. Everybody see that? And then they're going to say, okay, same thing for the cost function. They're going to say when X is 180, the next part says, what's the cost? Well, just come on up to the cost function. The cost is 48,600. What that means is, if you only produce 180, 1,000 policies, if the insurance company only produces 180,000 policies, it's going to cost the company more than it's making in revenue. It's not, right? It's losing money. All this zone is money lost. Everything before 360, right, cost is above revenue. But after that, revenue is above cost. And they're making money. Right? We good with that? So, whoops. Okay. So they're giving me revenue equals 0.18x. Profit is 0.083x minus point. Now, you don't need the zeros in front of the decimals. You can get rid of this one, too. You don't need those. They don't do anything, right? Okay, so I've got a profit and a revenue. Now, remember the relationship. Remember the relationship that exists there? Profit is revenue minus cost. You want to always get, you get a 3x5 card. Did I mention that on the test? All this is you could use the 3x5 card, write anything you want front and back. Definitely right. That's a real important relationship, right? Profit is money you take in minus money going out, right? So have that in front of your eyes. And they're asking me, what are they asking me? Oh, find the cost function. They're saying find cost. So can I take this little thing here and solve for the cost function? How do I solve that for the cost function? Well, a couple things we could do. I could add the cost function over to the other side. Cost plus profit is revenue, and then subtract the profit function. So cost is revenue minus profit. Is that okay? There's other ways you could have done that. So I just manipulated the equation around to get cost alone. Why? Because they're asking me for cost. They're saying, what's cost? Right? What is C of X? So cost is revenue minus profit. So therefore, it's the revenue function minus the profit function, isn't it? Revenue minus profit. Revenue, profit. Is that okay? Now, what do you do when there's a minus sign? Remember from your algebra days? That's to push your algebra back there a lot, huh? What do you do with a minus sign up against the wall of a parentheses distributes, huh? Like anything up against a parenthesis, it needs to distribute. Boom and a boom. So that's 0.18x minus 0.08. Did I lose the x? I did, huh? Kind of not doing a very good job there. So minus or plus. Everybody see why that became plus 0.9? So this is what cost equals. And that's 0.18x minus 0.083x. I lost the x again. And what is that? 0.097. Is that right? X. And there we are. That's the cost function. They're going to also ask me for the break-even point, which I'll do in just a minute. But are we good to there so far? So you see what I did. So I did this work first to find cost. So I just wrote down the relationship that exists between profit, revenue, cost. Profit made by a company is revenue, money taken in minus cost what they put out. I solved for cost. I moved the cost over here, subtracted the profit. Cost is revenue minus profit. I took revenue minus profit. So there's the cost function. Okay, now let's go forward and figure out what's the break-even point, because that's their other question. So what is the break-even point? Well, earlier I said break-even, a few minutes ago, we said break-even is when revenue equals cost, and of course that's true. It is when money coming in equals money going out, huh? But and you could do that. You could use that, but you'd have to use the cost function that we just found, which is okay. We just found the cost function. So we could do that, right? I just found the cost function, the work I just did. So I could plug the cost function in here, the revenue function in here, and solve that equation. That would be fine. What's another way, though, that would be a little quicker? How else do you know when they break? What does profit equal when you're breaking even?
0.
0. When you're breaking even, you're making no profit. You're not losing, it's not negative, you're not gaining, it's not positive. Right? There's two ways to say breaking even. Revenue, money coming in equals money going out, or profit is exactly 0. It's not positive, it's not negative. Does that make sense? That'd be quicker because I've got the profit function right here. So I could take 0.083x minus 0.9 and just set that equal to 0. That's profit, right? And solve that. Add 0.9 to both sides. 0.083x is 0.9 divided by 0.083. X equals, somebody got that? Anybody? It's 10, 11, maybe? I'm guessing. I don't know. Guessing an 11. No? Am I just way off?
10.84.
10.84? Do they want me to round it, or what do they want me to do? Oh, I don't know, because I didn't even enter that part, huh? They'll tell you. I don't want to bother fooling around. We got other problems we got to solve. They'll say round or don't round or something. I don't know. They'll tell you in the blue box. They always tell you what they want you to do. Is that good to theirs? Everybody see how I did that? So it's two things you want to know, on a 3x5 card for the next test. Is profit is revenue minus cost, and break even is when revenue equals cost, or another way you can say that, profit is 0. You're breaking even when you're making no profit, right? Or when your revenue equals your cost. Either way. If I would have solved the revenue equals cost, the answer would have been the same. Would have been exactly the same. Am I confusing you? I don't think I want to take up, feel free to grab me after class if you want to see that. But I want to get on to other problems. I don't want to solve it a second way. Is that okay? Okay. Suppose you're the manager of a firm. Accounting department has provided cost estimates. Sales department, sales estimate. I don't know. We don't need to read all those words. Blah, 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 blah. Cost, revenue. I'm just a math teacher. I don't need all those words. Just give me the formulas. All right. Cost and revenue. What am I? And they're what do they want? Break even. So what am I going to do? Remember, we have two ways of saying break even. Profit equals 0, but I don't have any profit anywhere up there. So I don't want to do that one, huh? I want to do it the other way. Break even. Cost is revenue, or revenue is cost, whatever. They're equal. So just set those equal. So sometimes we use profit 0 when they say break even. Sometimes we use revenue equals cost, whatever's more convenient for us. So cost is 300x plus 10,500 is revenue 375x. All right. Can you solve that? Solve that for x. So when we have x on opposite sides, we subtract the lower one, huh? Or really, it's either one of them. It doesn't matter. Get rid of one of them. So 75x is 10,500. Divide by 75. Is it clean? What is it? 140? 140. They have more questions than just that. I need to go on to their other questions. But x is 140. So let's go back and put that in. Think about it for a second. The cheaper something is, the more you want it, right? I mean, the more you're willing to buy it, right? Does that make sense? So if something's cheaper and cheaper, so in other words, if the demander, the person buying the product, the demander, if the price, so look at this dot, just compare like being here on the curve versus being here on the curve. What's the difference between those? Here, the price, this is the price. The price is what? Something over here. It's low. It's a low price, and it's a high quantity. Meaning if you make something really cheap, a lot of people will be willing to buy it. Right? So that's why demand curves always go down to the right. That's how the demander feels. Right? As the price goes down, they go to the right. They want more quantity. But how does the supplier feel? As the price goes up, they want to sell more. That's how the seller, the supplier, feels, right? Their curves always go up to the right because they want to sell more when prices go higher. But demanders want to buy more when prices go lower. All right. So all that said, they want to know equilibrium. They want us to find, where's the equilibrium? It's right there where they intersect. That's how economic systems work. I mean, that's part of the deal. Is they meet somewhere in the middle where the supplier and the demander can be happy together, right? So at that and that. So they just want us to look at the graph and find that. So how do you know what that spot is? What is that x value here? Yeah, we could, well, I can make it big. I can't. It's a picture right now, so it won't work. But anyway, so can you guys see it okay? It's between 66 and 132. How do you find what's halfway between 66 and 132? Yeah, how do you find the middle of any two numbers? Add them and divide by 2. It's called averaging, huh? So to find the middle of those two, add them and divide by 2. Was that 198 over 2? It's almost just under 100. It's 99, isn't it? So that's an x value 99. And what's the y value? It's whatever. Is that what it is? 198 plus 132 divided by 2. It's right. It's right there. So what's that? 330 over 2. And 150. Yeah, 165. Right. 165. So now they want the quantity. What's the quantity? Quantity's here, 99. Next one they'll say, what's the price? And this is the price, because price is the y-axis, $165. So they'll sell 99 items for $165. That's where the supplier and the demander will reach agreement. Does that make sense? So it's just finding the point of intersection on that. Is that good? You guys got that copied down? Am I whipping too fast over this? Questions on that one? Okay, so here we go. So first off, they say find the price for a demand of 17,500. Which one of those is the demand equation? Well, this one is, because they said Q is demand for that one. So, okay, so I use the demand equation. P equals 455 minus 6/5 Q. That's the demand one. And they're telling me find the price for 17,500 fans. So find what P is when you plug in a Q, a quantity of 175,000 fans. So if the market demanders are demanding 175,000 fans, what must the price be? So you guys have a calculator? I would just hit the buttons on my calculator. I would just go 455. You know how to do that in your calculator? 45 minus 6 divided by 5 times 175,000 and hit the equals button. And tell me what it is, please. I mean, I could do it in my head, but I hate to show off, so I'll just let you guys tell me the answer.
Anybody?
Negative 20,545.
Uh-oh, is it negative? That's not good, huh? Am I doing something wrong? What am I doing wrong, guys? P is the price. Q is, oh, what am I doing wrong? Do you see it? It's a tiny little phrase. Is it on the board up there? Yeah.
I don't like it when they do this. I'll try not to do this to you on the test. I think this is just kind of weird. See, they say Q is the demand in thousands. It's that little phrase in thousand, which means I plug in 175 and not the zeros. They're saying it's already in thousands. So that's just, I don't like that kind of thing. That's just, we got enough to worry about without them playing those games. So they're saying it's in thousands. So it'd be like if I said, hey, I'm going to tell you the population of Fresno City. I'm going to tell you in thousands. You ready? 28. So I mean 28,000. That's what they're doing. You know what I mean? So when they say in thousands, then we don't say the thousands. We don't say the zeros. So in other words, I need to plug in just the 175. Yeah, that negative answer shouldn't be negative. So yeah, so just plug in 175. All right, so I'm hoping to get a better answer now. 245. So, and that's dollars. That's a price in dollars. So in other words, if 175,000 people are demanding the product, it must be at $245. That price will produce that kind of demand. Good for the first part? Okay, let's see. Let's go back to the live and all right, so now the demand equation, or no, I mean the supply equation. Oh, no. Oh, this is another demand question, isn't it? Oh, but they're going, okay, no, this is important. We better do this. Yes, they're still talking. I just assumed. I didn't read. I just assumed. But when I read, I saw, no, they're still talking about demand, aren't they? So we're still dealing with the demand equation. We're not on to the other one yet. We're not on to the supply equation. So we're still dealing with the demand one. We'll get to the other one in a minute. But this time they're giving me the price, don't they? And they want me, this is harder then, a little more algebraically difficult. They want me to solve for Q. You guys with me? So same equation, but they're making this equation go the other way. They're giving me P, price. They're saying, hey, the fans are selling for $251. How many are going to be demanded? What's the quantity that the market is going to demand if we set the price for the fans at $251? All right, so I need to solve that little equation for Q. These are the kind of things I've noticed over the years really give students trouble. These fractions, are kind of a pain. One thing you could do is just, you know what you could do on this one? Is just make that a decimal. You could just divide that in your calculator. That'd be 1.125, wouldn't it? 1.2, would just be 1.2. Yeah, that'd be easier, but let me give you a way, and that's fine, that's what I would do on this one. But sometimes, guys, if that was like a 7 down there, 6 sevens, the decimal would just like go forever. And then you really would need to not do it. Because when the decimal goes forever, you'd have to round it, and if you round it, you might throw your answer off. So let me give you a method that'll work even if it's an ugly one. But this one, you could just make a decimal. So how would we do it just dealing with the fractions straight from algebra? Well, yeah, I don't want to do that. You multiply by 5, 6? Yeah, because of the problem. Well, if you got this alone first, you could. That's true. Yeah, let me just do this. That's true. That would work. There's a million ways. Let me give you something that is like surefire and will always work. A lot of terms, few terms, whatever. Just whatever. That's the problem, right? Isn't that the problem thing right there, right? That 5. So just get rid of it. Whenever you got a denominator and you don't want it, it's easy. Well, it's not easy, but there's one reliable thing. It cancels there. You multiply through by that denominator. Everybody there. You got to do equal treatment, right? Whatever you do to one side, you got to do the other side. All the terms, equal treatment. If they were equal before, treat them the same, they'll still be equal. Okay, and then 5 times 251, 1255. And 5 times 455, I don't know. 2,000 something. 2,100 something. 22, I don't know. What's 5 times 455? 2275, thank you. Minus, and this is just 6Q. Notice the 5s are gone. That's why I did it, to get rid of that fraction, to get rid of that other 5. Does that make sense? So, I'm not done yet, but the rest will be easy now that I don't have fractions anymore. So everybody see that first step? That's going to come up a lot. I know that it's hard for everyone to get used to. So multiply through by the common denominator. It cancels here. Remember, that's its job in life. A lot of times when I'm teaching out to the students, we'll multiply these and get 30. And I'm like, no, that 5 canceled out. He's not there anymore. So make sure you cancel that out. Right? That's why we even did it, huh? Was to cancel that out. Let him do his job. All right, and then how do you finish solving for Q now? Yeah, subtract 22. This is probably not the easiest way to do this one, but this is a reliable way that'll always work for you when you have fractions. What was that, minus 1,020? Minus 6Q divided by the minus 6. Is that something nice? What is it? 170. Okay. So the quantity demanded will be 170,000, but it's already in thousands. So. Is that good for that part? So when you have a denominator, multiply through top, by that time, don't forget to cancel it. That's why we're even doing it, to get rid of the fraction. Multiply the other ones and then finish off. So just get rid of, so basically, I have fractions, I get rid of them. If there are fractions in there, I just multiply through by the common denominator and get rid of it. Okay, let's. Okay, so now we're talking about supply equation. So the supply equation, instead of the demand, is the P equals 7/5 Q. It's this one. This is the supply, because it says supply. All right, so, and then where they're telling me, find supply, the price is 364. So the P is 364. 7/5 Q. Yeah, and if you wanted to do it the quickest way, it would just be this would be a great situation to do what you were saying, multiply by the reciprocal, upside down, 5/7. If you want, how about I'm just going to do the same thing. I found students kind of like it when I just do the same thing every time. So, but again, it would be quicker just to multiply by the reciprocal. But just to keep it same, you could just do the same thing. Just multiply through by the 5, right? Whenever you have a fraction, you want it out of there, multiply all the terms by it. It cancels out here. The other side is something big. 2,000?
Yeah.
Just straight?
Yeah.
Okay, thanks. So 2,000 straight, divide by the 7. Oh, it's going to come out ugly. You got to round it, huh? Where is it?
No, it's
1820.
Yeah.
Yeah. I got confused. I thought that 20 was 200 in my mind. 1820, thank you. And is that nice, 1820 divided by 7? 260, okay, good. 260, okay, so 260 on that one. So, yeah, did I mess up?
So it says Q is the supply, so you don't you put...
No,
Or is it because you're solving for Q?
Yeah, Q yeah, I'm sorry, you're right. Q is the supply. Yeah, Q is the supply. I solve for Q, that's the supply. That's what they're asking for.
Oh, okay.
Yeah. That is the supply. Is that good? And then I assume the other one, well, there's 5 parts though, huh? Maybe we're gonna... So I'm hoping there's some way we can just kind of eyeball it and pick the right graph. What do you think? I don't know. It doesn't look good. Maybe we better harken back to what were our answers we got, guys, in the last one? So last time, okay, so we have 3 answers, right? I'm just going to look back to our answers. So first off, we used the demand curve, and what did we get? We got, the first one was they gave us, it was supposed to do, wait, what goes in is price on the vertical axis? I think price, yeah, if you look back, price is always on the vertical axis, and Q is always on the horizontal. So Q is like our X, in other words. Q is like our X. That's kind of reverse. I would think P comes before Q, but whatever. So Q is like our X, and P is like our Y, huh, on the graph, if you look back at the other ones. Okay. And so for the demand curve, what did we get? We plugged in a what was part A? We plugged in a quantity of, or I can just look back here. We plugged in, for part A, let me go back. Part A, we plugged in a quantity of 175. Here I am back on part A. Quantity of 175 and got a price of 245. So quantity 175, price 245. 175, 245. Let me go forward. 175, 245. And then part B, part B, we plugged in, what did we plug in? Price 251 It is due next time at class time. So on Monday, no, we don't have class time. On Tuesday, this is due at class time at 1:30. This first section, 3.3. Have a good weekend. So the real graph is this one here, and it's that one there because it has those points. Over 175, up 245. Those are all three. Those two dots are here, and the other dot is like there. Those are where the three dots are on that graph.